This unit, if people pay attention and try really hard, is an easy unit. And if you miss it, because it's regressions and a whole bunch of calculator buttons, you lost. So attendance is crucial. If you're not here, you won't know how to use your calculator, which means you won't be able to answer about 70% of the questions on the test, because you won't know how to get an equation. So the regressions, which is what we're going to start talking about this week, but not right now, because we're just going to go through graphs. What regressions do is you type in data into list 1, list 2, and it spits out the equations for you. So it'll give you the linear equation, or it'll give you the quadratic, or it'll give you the cubic. But if you don't know how to type it into your calculator, the equation can't come out. Okay? So some people are like, oh, I can just do it on my calculator. I don't need a calculator. Okay, good luck. I can't. I can't look at the data and just be like, oh, I'll just get you a line of best fit. 96.2798773 x cubed, and then it has an r squared value of 99. No, I can't do it. I type it in, calculator goes voila, and then I just type down the numbers. That's what I do. Okay? You can't do it without your calculator, and you can't do it without knowing how to type it in. Okay, so first off, what we're going to talk about is we're going to talk about polynomials. You guys have talked about polynomials a lot in your day. A linear equation in grade 10. That's the degree 1 polynomial. Then last year, didn't matter what class you were in, you talked about quadratics, which is a degree 2 polynomial. And then all we're adding today, this year is cubics, which is degree 3. Nothing crazy. Okay? So what is a polynomial? I'm going to, instead of giving definitions, I'm going to show you equations of what is a polynomial and what is not. So what is a polynomial? Y equals 7. That is a polynomial. Why is it a polynomial? Well, it's actually a constant function. It is specifically this, y equals 7. That would be like a constant function. The entire function looks exactly the same. So y equals 7, for example, you would go to 1, 2, 3, 4, 5, 6, 7, and the entire graph is a horizontal line at 7. It's a constant function. That is the equation y equals 7. It is a polynomial. Because in order to have a polynomial, your exponents have to be whole numbers. Okay? So what is polynomial? Polynomial exponents are whole numbers. Now some people will say to me, this one doesn't have an exponent. It actually does. This constant function has a variable behind it. You just don't know it. It's an x to the 0. What is anything to the power of 0? Nope. Everyone else says 0. Anything to the power of 0 is 1. In 10 common, you're taught that. Anything to the power of 0 is 1. You're also taught it younger than that, too. But x to the power of 0 is 1, so it goes away, and that's why we end up with just a 7. Do you see that? So whole numbers, and then any value greater than 0. So 1, 2, 3, 4. Okay? So another one would be a linear. Y equals like 3x plus 4. It's a linear, or a degree 1. And the reason why it's a degree 1 is the largest exponent is a 1. And some people might say, well, that's the only exponent. No, remember the 4 has an x to the 0 on it. We just don't have to write it. Right? That's a linear. We did that in grade 10. Then we had quadratic. Doesn't matter what math course you were in last year. 2x squared plus 6x minus 1. This is a quadratic. Or degree 2. Once again, it's degree 2 because my largest exponent is a 2. Now you have to watch yourself because sometimes it can be not trickery, but it's like, do you actually understand what's happening, or are you going fast? Sometimes they write the equation out of order. They might write it as y equals 6x minus 1 plus 2x squared, and the largest exponent is a 2, but you don't spot the 2 because you don't have it in order, right? So it makes a difference. All right. Then we have the last one, which is what we're doing this year. And it's not the last polynomial. There's numerous polynomials after this. There's degree 4 and 5 and 6 and 7 and 8. The only catch is that we have to have 0 or higher as our exponent, whole numbers, correct? We can't have decimals. We can't have negatives. All those things would make something different. But for 30-2, we max out at cubic. So we're going to have y equals negative 3x cubed plus 7x squared minus 2x plus 4, let's say, like that. And that would be not linear, not quadratic. It would be cubic degree 3. And once again, it's a degree 3 because our largest exponent is 3. And I can write that out of order. So I want to prove that again. I want to rewrite this one. I could rewrite it as like y equals 4 plus 7x squared minus 2x minus 3x cubed. And this would still be cubic. Yeah?
Yep.
Yeah. Okay, what is not a polynomial? Anything but that. So, basically a polynomial is an exponent with whole numbers. Not a polynomial would have, it looks the same, but your exponents aren't whole numbers. So, for example, you could do like y equals 7x to the negative 1. That would be that. It's not a whole number, it's an integer, right? Out. Another example could be like y equals 4x to the 1.6. Something like that. That would be out as well. It's not a whole number. We could also have y equals 8 over x squared, let's say. Now some people say, well, that's still a whole number. That's a whole number. You told me it was a whole number of classes, you said, Lepp, you're a liar. No. Because in grade 10 you were taught when you had an exponent or something down in the denominator, you could move it to the numerator because we have to have it up here in order to justify if it's a polynomial or not. And when you move something from the denominator to the numerator, your exponent changes signs. So this is actually the same as 8x to the negative 2, and then it fails. Okay? So it may look originally like it's a whole number, but we have to have our variables in the numerator before we can decide if they're whole numbers. Okay? So technically, fun fact, you should always move them up before you decide. Another thing would be like y equals the square root of x. Now people say to me, Mrs. Lepp, there's an exponent of 1. Once again, you're a liar. That's a whole number. But in grade 10, you were taught to write mixed radicals, right? You were taught to write entire radicals. You were also taught to do rational exponents, which is what we need to do here. So how did we do rational exponents? Let's go back in case you forget. You have the 2 here. That's our index. So if we don't have a number, our index is a 2. The index is a little number above the radical symbol, right? So our index is a 2. So what we want to do is we want to take that number and drop it underneath the other one. So this is the same as x to the half. You see that? And is half a whole number? No. It's irrational. So that doesn't work too. Make sense? A lot of people will fall to, like, I could do this. I could go y equals pi. I put it in this column because it's a polynomial. Because pi is just a number. It's 3.14159. That's actually a constant function. I could, if I went to draw it, I would go to 1, 2, 3, 4, 3.14, be like here. And I would have a horizontal line. That would be y equals pi. Right? It's just a horizontal line. It's just a constant. Still works. And the other thing it can't be, which gets people, is like y equals 4 to the x. Not only is my exponent not a whole number, it's also not a number. It's a variable. That's actually an exponential function, which we're going to deal with this year. We do polynomials, and then after polynomials, we do logs and exponential. After that, we do sinusoidal graphs. That's like the trig graphs, not trig triangles. We don't have them. And then we finish off with probability. Okay? All right. So let's scroll down here. And by here, I mean over. Go to here. So we're going to look at degree 1 functions. These are grade 10. You did these all in grade 10. And we do quadratics. We did them all in grade 11. The only thing new to you this year is cubic. So most of this should be a repeat for you. Okay? So we're going to look at a linear function, y equals ax plus b. We don't say mx plus b, we do ax plus b, because then squares we're going to do, yeah, ax squared plus bx plus c. Then cubics we're going to do ax cubed plus bx squared plus cx plus d. So we just do variables as they go down, okay, by a, b, c's. So this one we know is degree 1 and linear because its exponent is a 1. Do you see that? X to the 1. So it's linear because it makes a line, and it's a degree 1 because its largest exponent is a 1. Okay? We're going to talk about what the a and b do. Now, what I want to talk to you about first is x-intercepts. Okay? If I walked up to you on the street and I said x-intercept to you, not even hello, not even how you doing, I just walked up and I said x-intercept, which I really want to do is try your parents just to see what would happen. Okay, I'll try it out. If I just walked up to you and I said x-intercept, you would look at me and be like, what? No, you wouldn't, because after this moment you would say y equals 0. That should be what comes out of your brain. Not hello, Mrs. Lepp, or anything. Are you okay? Not even that. Just if I say x-intercept, you say y equals 0, Lepp, and that's it. Boom. And then we walk away. And then we think some secret code. Yeah. Should I be afraid? So y equals 0 should be what comes out of your brain. I guess your mouth, not your brain. At least your brain, but I don't want to either. But y equals 0 is what should come out of your mouth, correct? And if I say y-intercept, if I walked up to you and I said y-intercept, what should come out of your mouth? X equals 0. And the reason why that is, in order for it to be a y-intercept, it has to be on the y-axis. And anything on the y-axis, x equals 0. Hence, x and y-intercepts, yeah? So, if I have my equation in this format, where it doesn't, it's standard form, where it doesn't have brackets, do you see that? I'm going to look for the y-intercept on it. So I'm going to do it up here. Y-intercept x equals 0. So I'm going to have y equals a times 0 plus b. What's a times 0? 0. So any term with a variable, technically when you're finding the y-intercept, is going to go away. Correct? Any term with a variable is going to go away because it's going to turn, the x's are going to turn to zeros. 0 times anything is gone. Yeah? So I'm left with y equals b. So my y-intercept of every linear function is always going to be the constant. And actually of every polynomial function, it'll be the constant. The constant is the variable, is the number stored without a variable. Because it's going to be the only thing that's not going to go away. Anything with a variable is going to turn to 0. Right? So for this one, my y-intercept is actually 0, comma, b. 0, comma, b, if I'm using the equation, right? So, if I give you this, that's my equation, my graph of my equation. My equation is of the form y equals ax plus b. B is my what, guys? My y-intercept. So what can you tell me about my y-intercept on this graph? Someone whispered it, and they were right. It is what? I think Ethan, you might have whispered it. It's positive. This bad boy is positive, correct? So can you tell me it's 1.7 or 9.3 or 5? I have no numbers on here. So can you literally tell me what it actually is? No. But you can say that B has to be what? Positive. And how do we write that? greater than 0. Right? My b has to be greater than 0. We agree? Okay, cool. What about this one? What can you tell me about my y-intercept now? It's less than 0. It's negative. And my y-intercept in the form y equals ax plus b, you know my b has to be less than 0. Okay, let's talk about the other part of this. So the leading coefficient is the coefficient that leads the equation. That's why it's called leading coefficient. So the leading coefficient is a little thought bubble over here. The leading coefficient is the number in front of the largest exponent. So it's the number in front of the largest exponent. It leads the equation. So in this case, it would be the a value. Do you see that? In this case, the leading coefficient is the a. Because my largest exponent is 1. And this is the coefficient that leads it. Leading coefficient. Kind of makes sense? Coefficient means number in front. Leading coefficient is the number in front of the entire equation if you wrote it in order, right? Sometimes it's not written in order, right? That's how they switch it a little bit. So, the leading coefficient, we're going to write this up here to remind ourselves. And this works for every function. The leading coefficient tells how the graph ends on the right. Tells how it ends on the right. That's what the leading coefficient tells us. Remember, if I'm writing things, it's you actually write them down. Right. Yeah, it's a crazy concept. Throw that out there.
You didn't write this down. You didn't write this down. I'm writing for you.
Yeah, I'm really good at this.
Yeah.
Students, it's not a struggle for me. All right. So it tells how it ends on the right. So let's look at this one. What? No. How it ends on the right. How does this graph end on the right? Up or down? Up. So my a is greater than 0. So because this ends up on right, a is greater than 0. What about this one? It's less than 0 because it ends down on right. A is less than 0. Yeah.
What if you can't put the leading coefficient positive and negative?
You can write positive or negative. Just watch yourself because on the multiple choice and numeric response, they're going to give a is greater than 0, a is less than 0. So you need to know that means positive. So writing positive and negative works as long as you correlate that a greater than 0 means positive. And a lot of people don't. So they'll want to look for the word positive in the multiple choice, but it'll say a is greater than 0. As long as you know that's the same. All right. The other thing about odd functions, so odd degree functions are degree 1 and 3. That's all we get, because we get 1, 2, 3. That's it. Odd degree functions, disco. Amen? I don't know what you're doing. Is that almost a phone? Could have been. Close. Kind of afraid. All right, we're good. Don't worry, guys. We're okay. So, degree 1 and degree 3 functions disco. So that means that their arms end in opposite directions, correct? So we know if it ends up on the right, what does it do on the left? Down. And if it ends down on the right, what does it end up on the left? Up, because they disco. Okay? Degree 2 functions, even ones, go in the same direction. They don't disco. Okay? Now, the number of x-intercepts. Linear functions have how many x-intercepts always? 1. They can't have more. They can't have less. Because they disco, and their arms are in opposite directions, because they disco, they're going to for sure get what? Because they're a degree 1, they max out at 1. So the maximum number of x-intercepts is equal to the degree. I'm going to leave that as a little side note over here. Maximum number of x-intercepts is equal to the degree. So if this is a degree 1 function, I max out at how many? 1. And because it discos, I have to have 1. So linear have 1. That's the only option they have. They will have 1. They can't have more. They can't have less. Right? Now some people say, but if it's a horizontal line, then it has none. That's a constant function. That is not a degree 1 function. Okay? What is fantastic about discoing functions? The ones that disco mean they go up and down for life. They also go right and left for life. Their domain and range are the easiest things ever. There's no restriction. Now, if you came from 20-1 and you liked interval notation was the little rounded brackets from one number to another. C'est la vie. Great that you did. Say bye-bye to it. You can't use interval in 30-2. You have to use set notation. If you use interval, you will get no marks. So let it go, like Elsa would say. Okay, so our domain is going to be... Now, I need you to know why you write the domain that you do, because I feel like you guys write stuff but have no clue. You just kind of memorize it. That's not good. When you use this weird squiggly bracket, it's called a curly bracket. I like calling it a squiggly. They're not going to question what it's called, so you're fine. But this little S forward, S backward situation, when you have one of them, it means something different. But when you have two, an open and a closed one, it means the setup in mathematics. Every single symbol means a thing in mathematics. So the two curly brackets together, which I like to call squiggly, they mean the setup. Then we have to decide what the variable is. Now, our variables are up here. Our y is a y and our x is an x, correct? But you know that in like 20, no matter what one you were in, if they were talking like the height of a ball being released and it was like negative 6.5 t squared plus 4.5 or something like that, now our variables are our x is t and our y is actually h of t. So we would have to use those in our domain and range. Do you see that? Okay, cool. These are x's and y's, so we don't have to do that. We get to use x's and y's. But that's why you have to state what the heck the variable is. So it means a set of x values. So now I'm telling you, and you're telling the world when you're writing this, that the variable for x is x. It's not t. If I was using h of t equals t, I'd have to put a t there. See what I'm saying? But this equation had an x and a y. So I'm going to say x. Then you do a straight up and down line. Then that's for two straight up and down. But you do a straight up and down line because it means such that. Straight up and down lines mean such that. And you're like, well, that's ridiculous. Well, they do proofs in mathematics. Luckily, you don't have to do those. And if they use an up and down line, that means such that. So we have x such that. X is an element of the reals. And x is an element of the reals just means that every x value in the world exists. Okay? So, same thing here. You want to know what's cool about polynomial functions, unless they're a word problem? If they're a word problem, it might not be XER, because what if it would probably be a T, and it wouldn't be TER, because time doesn't exist everywhere, right? Or maybe T is greater than or equal to 0, because time can start at 0, right? So you have to watch yourself when it's a word problem. But when it's not a word problem, when it's just linear, quadratic, or cubic, the domain is x and element of the reals no matter what, because linears go on for life, quadratics go on for life to XER, and cubics do like a little like, ooh, in the middle. They do like a max-min little split, but they go on for life. So unless it's a word problem, domain is really easy. It's x and element of the reals for polynomials. Now if a disc goes like this one does, it goes up for life and it goes down for life. So what's its range? Y such that Y is an element of the reals. If there's no place it stops, it's Y such that Y is an element of the reals. For both of those. Okay, we're coming back, but for right now I want you to flip ahead to page 3, please. I want to solidify some stuff here. So we're on page 3, the bottom, right down here. Okay, all 4 of these on page 3 at the bottom are linear, degree 1, right? They're all in y equals ax plus b, true? So, I'm going to get you here. It says sketch the graph of the following equations given the particular values and state the domain and range. So let's look at this first one. You're going to do B, C, and D. So this one wants a linear line. This is linear, correct? So that means it wants something like this or something like this, right? It wants a linear line. Is everyone paying attention? Yeah. So it wants a linear line. Here's my Cartesian plane with its arrows on the end because it keeps going on for life. But this linear line has restrictions. It says a is greater than 0. A is my leading coefficient. What does my leading coefficient tell me about this graph? How it ends on the right. So if it's greater than 0, it ends what on the right? Up on the right. And because it's linear, what does that mean it does on the left? Down on the left, because it's going to disco. Correct? Up on the right, it's going to be down on the left, because that's how it has to go. What does this give me? It's my B. What's my B always? My y-intercept, because when I plug 0 in for x, that's going to go away. So I have a y-intercept that is what? Positive. So I need a positive y-intercept. There. So I put a lot of thought into it. I just went above the x-axis and put a dot somewhere. I did not put a lot of thought into it. So your y-intercept, this little blue dot, could be anywhere from the x-axis above, right? But not including the x-axis. And then I need to end up on the right and down on the left, and it needs to be a straight line. Okay, get ready. Oh, I didn't even go through my y-intercept. It moved. It's now here. That's how much thought I put into it. So that would work, correct? This could work. Would that work and follow this too? Positive y-intercept, still up on the right, down on the left? Yep. What about this? Down on the left, up on right, positive y-intercept. Still works. Correct? Okay, you guys try B, C, D. Go. All right. AX plus B. If A is less than 0, that means it is down on right, up on left, and this means positive y-intercept. All right. So we need a positive y-intercept. There. And then we need to be down on right, up on left. Something like that. Could it be more like flatter? It could be like this, correct? Can it be completely horizontal? No, that would be a constant function, not linear. Okay, this one is up on right, down on left, because linear has to disco. And this is negative y-intercept. Give myself arrows. Negative y-intercept will go here. And it needs to be up on right, down on left. Up on right, down on left, straight line. Correct? And then this one, we have down on right, up on left, negative y-intercept. I'm going to make it here. I'm going to be a rebel. Right there. Down on right, up on left. There we go.
What?
Even more of a rebel. Watch this. Also would work.
Because there's
Right?
down the
Still down on right, up on left. So you can have varying levels. Okay. Go back. Cubic function. So odd degrees do disco. Cool, but we're going to go to an even degree because we did it in grade 11. Okay? Even degree functions can look like this. We did these in grade 11. They can look like this. And have how many x-intercepts? 2. Now I'm allowed to short form x-int because these are my what? Nodes, and no one is marking them. Correct? On a test, am I allowed to short form anything? The answer is no. You can if you want to lose marks, or you cannot if you want to keep your marks, right? So it is optional, I guess. It shouldn't be. Do not short form. You know, short form all you want. No one's marking them, right? So we can have 2 x-intercepts, or we could have 1, where it has a point of tangency and it bounces. You actually have 2 x-intercepts, they just happen to be the same, correct? So that would be 1 x-intercept. Or, unlike linear or cubic, you can have none. And the reason why you can have none is these graphs are not disco, right? They're all in the same direction. So the whole graph could be completely above, or the whole graph could be completely below, and you could have no x-intercepts. But if a graph discos, at some point it has to cross through. So at minimum, you're going to have 1 no matter what if you have a discoing graph, right? Because it has to cross through somewhere. But these don't. So you can have 0 x-intercepts. All right. My A is still my leading coefficient. This still tells how it ends on the right. What's different is about how it ends on the left. So technically, your A value tells you how it ends on the right and the left if it's a degree 2. And the reason why is because they end in the same direction, correct? So if it's positive, it's going to end up positive on the right, but it's also going to end up positive on the left because they end in the same direction, degree 2, even degree function. And in the same, they don't disco. And then this is my constant, and my constant is my what? Y-intercept. And the reason why it's my y-intercept is because if I walked up to you on the street and I said y-intercept, it should say x equals 0 to me, correct? This ax squared would become 0. This bx would become 0. So all that would be left is the c, because x would equal 0. So your constant is your y-intercept. So for this case, it would be 0c. Now, some people mess this up because they'll get an equation with a bracket in it, and then they'll say, oh, the number by itself is y-intercept. It's not. So this only works because this is in standard form. If I had like y equals 3x plus 6 squared minus 2, a lot of people want to tell me that's the y-intercept. That is not. You would have to FOIL this out first, rewriting it twice, distribute the 3 in, and then move it over in order to get your y-intercept. Or we plug a 0 in here and we get 3 times 36 minus 2. It's not 0 at all. It's not the negative 2 at all, right? So keeping in mind, in order for your constant to be the y-intercept, your equation can't have brackets. You see that? So a lot of people on tests will be like, oh, the y-intercept is this. And it has a bracket in it. And I'm like, no, it's not. Okay? So let's look at this one here first. Say I give you this graph. What can you tell me about the leading coefficient? The leading coefficient is A. It's the one that leads the equation, right? What can you tell me about A for this one? It's positive because it ends up on the right. So it would be A is greater than 0. We agree? Okay, the second one, what if I give you this? What is your A in this case? Because it ends down on the right. It just happens to end down on the left as well because it's an even degree. Yeah. talking about concrete ground. Then, our last one, what if I do this? What's my A? Less than 0 or greater? Less than, because it ends down on the right. We agree? Okay, and it wants the y-intercept. So our C value. Because our C value is our y-intercept, right? So what can you tell me about C for this graph? C is what? That's my C, correct? C is what? Negative, which we'd say less than 0, correct? What can you tell me about the C of that one? This one? It's also less than 0. What can you tell me about the last one? Also less than 0. Okay. How many x-intercepts does this one have? 2. What about the middle one? 1, even though it kind of looks like 2. And then this one? 0. Now remember, quadratics go out for life, to the right and to the left. Well, you be to the left and to the right, because you're opposite me. Or this way it goes out for life, correct? And it connects in between. So if it starts here and it goes out for life, that means every x value is there. If it starts here and it goes out for life, that means every x value is there, right? So the domain is x such that x is an element of the reals. So is this one, so is that one. Every polynomial, unless it's a word problem, every x value exists because they go out to the right and left forever. Now our range, in order to get our range, we have to say it's greater than or equal to some sort of value or less than or equal to, correct? So this one has a minimum. Let's say the minimum is at 4 and -8. So we know this one has a minimum at 4 and -8. So what's the lowest this graph goes to? -8 or higher or greater, correct? So my range is going to be the set of y values, because we're using y, such that y is what? Greater than or equal to, because we're equal to it, right? It's right here. -8. Now, people don't understand why they put y-er, they just write it. Well, the reason why you put y as an element of the reals is it's -8. If we said y is the value of the integers, guys, this graph would go from looking like that to looking like this. It wouldn't be connected. If y is an element of the integers, I would only be able to keep the integer y values, so I would have dots without them connected, correct? If ever I have graphs where I connect those dots, then y has to be an element of the real numbers, because that means every decimal in the world exists on that graph, every y value, right? So the moment you connect your graph and draw it as a solid graph, you have to say, okay, y has to be greater than -8, but y also has to be an element of the reals so that we connect them all. We don't just have open dots. Okay? Now, B, does it have a max or a min? Max at where? 0. Let's say that this is 3 and 0. So my range is y such that, what is the highest y value on this graph? 0. Some people tell me 3. No, that's the x. The highest this graph goes to is the x-axis and then below it, correct? Less than it. So it's going to be y such that y is less than or equal to 0. Y is an element of the reals. And then this one we'll say has a maximum at 2 and negative 3. So this one's range is y such that y is less than or equal to negative 3. Y is now in the middle. So when you do your domain and range, you have to understand why you do what you do. Then you won't make a mistake. If you're just trying to memorize it, I get some random things coming out of it. Right? All right. This one has a maximum at 2 and negative 3. All right. So if you look here, we have the linears. And we flip over. Look. E, F, G, H, go. So I need this to be up on right and up on left and what does that mean? Positive? Positive what? Y-intercept. Because it is the constant. The constant is the number without a variable. The constant is the y-intercept if there are no brackets, correct? Okay. So we need to be up on right, up on left. So it could be like this. The key thing is the arrows both need to be up. It needs to be somewhat symmetrical. And you need to have a positive y-intercept. I get people doing this all the time, and there's nothing worse. Like, that ain't no symmetrical quad. Like, that's just... Or this. I'm like, was there an earthquake while you were drawing that? Like, I don't even get how. Very confusing. So, there was not an earthquake here. So, we're good. All right. This is up on right, up on left, negative y-intercept. So, it could be something like this. Up on right, up on left, negative y-intercept. Okay. This one. Down on right, down on left, negative y-intercept. Now, some people think that means that it has to go like this. It has to not cut through. Well, no, it could go like this. Just needs to be symmetrical somehow, correct? If there's a whole bunch of options. And then this one, down on right, down on left, positive y-intercept. There's one. There's another. You know what I mean? Okay.